again, and welcome to another GCSE Computer Science Theory lesson on Unit 2 Trace Tables. Okay, so here's an example question that you could be asked in the exam. What you need to do first is read and understand this pseudocode and then attempt to answer this question down by here. Now, an important thing to acknowledge to students is that trace tables are difficult and it's perfectly normal to struggle with them, especially in Year 10. In fact, most students don't become comfortable with trace tables until the start of Year 11. But it totally depends on the student. What it also depends on is your programming ability. So you need to be confident with programming before you can master your ability to fill out trace tables. So what I'll do first is I will copy this example into Paint. And I will start going through this trace table. For those who are new to trace tables or feel really underconfident about them, can I recommend that you ignore this to begin with and just try and figure out what the output is. So if you pause this video and just figure out what the output is going to be. Okay, so the output, by the way, to this program, because I've already done this, the output to this program is 1. If you've mistakenly come out with the answer of 3 or maybe even 4, that's okay. If you've put 3 or 4, that's wrong, but it suggests that you're on the right track, so don't worry about it. Now, I'm going to talk you through filling out this trace table, and I'm going to try and illustrate where I am at this code. So first of all, we're going to look at this code at the bottom here. We're going to be sending the integer value 10 into our parameter here. So x is going to be equal to 10. So first of all, count is equal to 0. And x is equal to 10. And there's no output required at the moment. Next, we run this line of code. Do until x is less than 2. Well, is x less than 2? No, it isn't. So we're going to do this loop until x is less than 2. So the next line of code, x is equal to x divided by 2. So that's 5. And the next line of code, count is equal to count plus 1. So what's 0 plus 1? It's 1. Moving on to the next line of code, loop. So we go back up to the top, do until x is less than 2. Well, x isn't less than 2 yet, so we carry on going. So now we're going to do x divided by 2, which is 2.5. Whether you wrote in 2.5 or 2, both are correct, both are acceptable. You can make the assumption that the decimal points are being truncated if it's an integer. And then we move the arrow down. And count becomes 2. And then we go to this line of code loop. So we go back around here. Do until x is less than 2. Well, x is 2, but it's not less than 2. So we're going to do this one more time. So we're going to divide x by 2, which is equal to 1. And then count is going to be incremented by 1, which is 3. And then we're going to loop here, go back up to the top. Now do until x is less than 2. Well, x is 1. 1 is less than 2, so we're going to skip this down. We're going to go straight to return x. And this is perhaps where students find functions quite confusing. This return x means return this value in place of this half count 10. So this half count 10 is now going to become whatever we return here. So x is 1. So we're effectively saying output 1. And there you have it. That's why our output to this code is 1. So there's your answer. A common mistake students might make is they might not read the code properly and think, Okay, counts up to 3 and then they'll output 3. So that's why I said don't be alarmed if you add 3 as your output. It could be that you've just got your x and count confused. Or if you put 4 or 2 as your output, it means you've just counted incorrectly here. Oh, by the way, I would have also accepted 1.25 as an answer there. If your trace table is formatted slightly different to mine, perhaps you've laid it out like this instead, you've spaced this, that is still correct. If the answer is correct, the answer is correct. It doesn't really matter how much you've spaced out your table.